Chapter 4, Section 31, De-Duplication, Part 3, De-Duplication Approaches. Data de-duplication is an essential step in data preprocessing, particularly when working with large datasets, where redundant or conflicting records may distort analytical results. Once duplicate records have been detected, we can use various strategies to handle them. The appropriate approach depends on the nature of the data, the specific business or research requirements, and the intended use of the dataset. The primary methods for handling duplicates include deletion, merging, modification, and alternative strategies such as flagging. This section explains these approaches one by one, including Python implementation. The most straightforward method of handling duplicates is deletion. It means removing redundant entries from the dataset. This approach is particularly useful when duplicate records provide no additional value, so we can eliminate them without losing critical information. For example, if a dataset contains customer records and some entries are exact duplicates with identical values across all fields, removing redundant rows is a reasonable action. In Python, we can implement deletion using the drop duplicates function from the pandas library. This method is effective when dealing with exact duplicates. However, in cases where records are only partially duplicated, such as when minor variations exist in certain fields, additional handling is required, which may involve merging or modification instead of outright deletion. In some cases, duplicate records contain non-identical but overlapping information. In such cases, merging is more appropriate than simply deleting all but one. Merging is a method that integrates multiple records into a single entry that retains the most relevant or accurate data from each instance. For example, suppose a dataset contains multiple records for the same customer, but some fields have missing or differing values. Rather than arbitrarily deleting one record, a merging approach can be used to consolidate the available data. In the sample dataset, where two entries exist for the same individuals with slight variations in the email address. Let's implement merging by Python. Here, the group by function is used to consolidate duplicate records based on the ID field, choosing the first occurrence for the name and the most recent email. Depending on the dataset and business requirements, merging criteria can be adjusted to retain the most frequent, most recent, or most complete values. Another method for handling duplicates is modification. In modification, we modify the data rather than deleting or merging records. This approach is useful when discrepancies in duplicate records arise from formatting inconsistencies, spelling errors, or variations in representation. For instance, consider a dataset where names appear in different formats due to capitalization differences. In this example, converting all names to lowercase ensures consistency, making it easier to detect and handle duplicates. By applying strlower function to a column, we can convert the text field in the column to lowercase. Here, we apply this function to the name column of the data frame df. Other modifications may include removing extra spaces or punctuation, correcting misspellings using fuzzy matching techniques, standardizing data formats, to ensure uniformity across records. In some cases, rather than removing, merging, or modifying duplicate records, it may be beneficial to flag them for further review. This approach is useful when full automation is not feasible or when human verification is necessary. For example, if a customer database contains similar but not identical records, automatically modifying or merging them could introduce errors. Instead, potential duplicates can be identified and flagged for manual inspection. We can use a duplicated function for flagging. Here, the duplicated function flags all rows that have similar names and email, allowing analysts to review them before making a decision. The keep parameter controls which occurrences of duplicated row are marked as true. The default setting of keep is first. In this setting, it marks all but the first occurrence of a duplicate as true, and the first instance remains false. When we set keep equals last, it marks all but the last occurrence of a duplicate as true, and the last instance remains false. When we set keep equals false, like in this case, it marks all occurrences of duplicate as true, ensuring every duplicate entry is flagged. This is the flagged dataset. Flagging is commonly used in industries where data accuracy is critical, such as healthcare and finance, where incorrect modification could lead to severe consequences. Handling duplicate records is an important step in data preprocessing that requires careful consideration of the dataset structure and the specific needs of the analysis. Deletion is the simplest approach, but is only suitable for exact duplicates. Merging is often preferable when data is partially duplicated and contains valuable information that should not be lost. Modification helps ensure consistency across records, especially when inconsistencies are due to formatting or minor variations. In cases where automated handling is not ideal, flagging duplicates for manual review provides a controlled way to address potential redundancies. The choice of the duplication approach depends on the nature of the dataset, the business objectives, and the potential impact of erroneous duplicate handling. By implementing the appropriate approach, we can preserve data integrity, leading to more accurate and reliable analysis. Thank you for watching. Please thumbs up and subscribe to my channel.